This is the week 3 assignment for FTH 202-51961. It is March 3rd, 2024, and this is for Professor John Nagy. Today we're going to be showing the internal parts of the double action revolver to show what malfunctions could certain parts lead to. The first component that we were to speak of is the hand. This is the hand here. The hand, if there was a malfunction with the hand, that could have an effect on the chambering because it could affect the rotation. The hand controls the rotation of the cylinder. If there was a malfunction with the hand, there could be a malfunction in the cylinder rotating as well as locking, because if the cylinder doesn't rotate with the right timing, it can affect the locking as well as the chambering and as well as the firing. Next we have the sear. This is the sear, the double action sear. I'll go ahead and release the hammer. As you can see, the sear is engaged with the trigger, and whether it was cocked in single action, you can see the sear and the trigger work together until it's locked and fully cocked. The sear is engaged with the trigger, and when the trigger is pulled, it releases the sear, which releases the hammer to fire the weapon. If there was a malfunction with the sear, it would affect the cocking and it could affect the firing of the weapon. The cylinder stop is here. If there was a malfunction with the cylinder stop, it could affect the locking phase, the chambering phase, as well as the firing phase if there was an issue with the cylinder stop. With the cylinder closed, when the trigger is pulled, the cylinder stop drops, giving the cylinder the ability to rotate. When the hammer is cocked, the cylinder stop drops, and then right after it drops, it's pushed back up by the trigger to lock the cylinder at the next notch. If there was a malfunction in the cylinder stop, it would stop the cylinder from It could stop the cylinder from rotating. It would affect the locking cycle, the chambering cycle, and also the firing cycle. This is the hammer strut. The hammer strut, if there was a malfunction in the hammer strut, it could affect the cocking. The hammer strut is what powers the hammer when the trigger is pulled and the sear is disengaged. The hammer strut is what powers the hammer. I'll show it with the trigger pulled. It powers the hammer to hit the transfer bar, which gives the pressure to the firing pin and fires the round. If there was a malfunction with the hammer strut, it would affect the cocking, it would affect the firing cycles of the firearm. In this part of the assignment, I'm going to be measuring the barrel twist of the Taurus 856 revolver. I do have the gun in the vise based on how my camera is set up. You can't see it in the vise, but it is in a vise. I do have my cleaning rod with the jag on the end, as well as the flag that I made. What I'm going to do is I'm going to pan the camera over so you can see the twist. I'm going to put the cleaning patch at the end of I have the flag at the 12 o'clock position. I'm going to put my finger here to make sure I get the right measurement. And as you can see, the flag did turn about 1/8 of a turn. And I'm going to go on and grab my pencil and mark it at the muzzle. I remove the cleaning rod and dislodge the patch to have no obstructions in the barrel. And then I'm going to measure the mark. Here is my mark that I was able to make with the pencil. I have my measuring tape. I'm going to go on and place it on the jag. I have a reading of just over 2 inches. With the flag only turning 1/8 of an inch and the measurement showing just over 2 inches, we will multiply it by 8 Since it was only 1/8 of an inch, an eighth of a full rotation, we multiplied that by 2, giving us 16, giving us a twist rate of 1/16 or 1 rotation in 16 linear inches. With it being just over 2 inches, it'll make it about 16.5, somewhere around that area. And when you look on Taurus's website, it does show that it has a 16.5-inch right hand twist. This is the closing of my week 3 assignment for FTH 202-51961 for Professor John Nagy. Thank you.